Hi everyone.
Good evening, ma'am.
How was your exam?
Ma'am, very good.
So let's start with today's session. Today, just I will summarize the week 5 lectures. Okay. So less people. So after the exam, they have taken the break.
Ma'am, there are two classes.
That tea hour is there for C. Okay. So in week 5, have you gone through that? Have you checked which topic has been covered in that week 5? So majorly it starts with mixer. What does it mean by a mixer? So have you seen any program, a concert where audio means like you can see that multiple mics are there and like music is going on. You can see that music players they will be playing different music instruments as well as someone will be singing those kind of things. You can see that multiple mics are there, right? So in that case, how are you getting the perfect music without any like sound interference or difference between the you can see in case of like music, voice also you are getting as well as drum sound you are getting, different instrument sounds are also you are getting. So how is it possible? This is the main whatever you are getting, how these things are designed, what is the electronic circuit behind that, how this mixer used to be giving the output, how the input is working and how the output you are getting, those kind of things will be clear from this week lectures. Basically, in this course, a ESTC course is focusing on the circuits. So here, these are the applications where you can utilize if you have the fundamentals clear in this circuit, then you can see the applications, whatever we are using, there only these circuits are utilized. So we are able to use those devices. So in case of mixer circuit, what happened? You will be having the multiple means inputs. Like you can see that like you are getting the sound from instrument one. For example, I can say that instrument any instrument one. Then again you are getting the signal from the instrument two. Then you are getting the signal from instrument three. So similarly, multiple instruments are there, but finally you can see that output, whatever you are getting, this is very distinct output without means like getting the interference or noise. So very clear sound you are getting. How is it possible? So actually here you are mixing this all this signal and you are getting the output whenever the mixing is happening, how it is happening and how you're getting this. So normally if you see any very big concerts are there, normally these are nothing but known as the signal 1, signal 2, signal 3, different signals you are getting. So similarly if you see normal mixers whatever used in that big event, those mixers are having 64 channels. 64 channels means what? 64 signals. Or you can say that multiple mics are there. So multiple mics are used these by using these 64 channels. Some may use one channel, some may so different channels means we can say that frequency also, channel is nothing but frequency also, we can say that. Okay, how this circuits actually works, if and why I told about this here, or professors discuss about these mixers in this week. So whatever you have studied, like you have studied KCL, KVL, and mesh analysis, nodal analysis. There, KCL, what happens? You are getting current I1, current I2 at a node, for example, or current I3. So
And these mixers are basically, this mixer is basically an electronic device, no?
yes, it is an electronic device only. Okay, it is one electronic device which mixes different signals.
To create one single output.
Y- Single output, not I have shown like this distinct signal. Distinct output means you will be getting different distinct outputs.
Okay, okay,
Okay,
okay.
so mic 1, mic 2, mic 3, it is there. Then you will be getting distinct outputs. Okay. So, but the
Okay.
thing is that how is it possible? How means like to get the outputs and all. So, whatever you are getting, distinct output means, for example, two means like instruments are there, and here you are listening that two instruments output together. Are you getting or not? That instrument one plus instrument two output together you are getting. That means it is mixing these two outputs and you are getting one output. Similarly, it may be mixing these two output and you're getting this output. That is also possible, right? Okay. So this concepts is very similar with your KCL. Like whenever you do this KCL, so in case of KCL, what you are doing? Like you are mixing two, three or n number of currents and output. You can get that summation of I. Okay. Similarly, whatever you are getting, 64 channels, you can get the single output with the summation of the 64 channels. Okay. So this is nothing but known as a mixing of 64 signals or channels or frequencies. Different way means the terms are used, but meaning is same. Is it clear?
Okay, ma'am.
So have you gone through the lecture? Any doubt is there so from the lecture?
No, ma'am, not now because of quiz.
Okay.
So, ma'am, in this whole week, we will study about this mixing.
Mixer is nothing but like I said, the applications whatever
So,
where we are using these electronic circuits. So just introduce the mixer and how the electronic circuit means works in this mixer. That those concepts will be clear.
okay, ma'am. Okay, ma'am. Now understood.
Just a second. System and yeah. So going forward, we can see that let's see take one circuit. So which is having the two signals. I'll say that how can you relate with the mixer? So this is one voltage source and this is another voltage source. We can say that V1 and this is V2, and this resistance is R1, this is R2. Let's say this is R, and the voltage appears across this R is nothing but Vx. Okay, so in this case, let's assume that current I1 is flowing through this R2, R1 and R2 through I2, and total current I is coming out of this. So in this case, we can just means like relate with the mixer. For example, mixer, what I told, this mixer mixes multiple signals. Okay,
So, ma'am, in
multiple.
this case, what is the mixer? The
Just
I1,
coming to
I2.
that. I'm just coming to that.
Okay.
Multiple inputs. Okay. So for example, this input is nothing but your mic one. So this is mic one output. Okay. This is mic two output. So like you can see that like someone is there, human being. So he is getting the mic one, mic two outputs together by mixing the things. Means what? This mic one is connected to drum. This is, for example, some voices there. Okay. Together, the mix of this signal you can hear, right? Are you following me?
Yes, ma'am.
So, how is it possible? Actually, you have
Basically,
this.
uh, in this, you're saying that mic one is basically output is voice of drum, and that is some voice.
Yeah, no, no. Mic one output is drum, mic two output is voice, and whenever you the human being hear about this together he is getting about this sound and this sound. Are you
Yes,
getting
ma'am.
or not? And you have seen like one device with multiple knobs, with multiple like channels like this, and multiple outputs will be there, and multiple inputs are there. Wherever in your like auditorium or anywhere, the mic, all the mic systems are there. Have you seen this kind of? Those are nothing but known as mixers. Have you seen? Like
Yes,
anywhere
ma'am.
any music concert is there, so those are nothing but and you have seen also, if you are changing these knobs also, different sounds used to come sometimes, like odd sounds you are not able to hear also, right? So that
Yes,
means
ma'am.
some adjustment you have to do here, such that you will be getting the good sound. So those devices are nothing but known as mixers. Okay, so how these mixes are designed, how these like sounds are controlled by controlling this R1, R2 and V1, V2. Are you getting?
Yes,
So
ma'am.
in that way only this is related. Is it clear?
Yeah.
And this circuit you know already, very familiar with that. If you have the source and resistance, and here what happened, two sources are there, V1 and V2, and two resistances are there, R1, R2. And from here we can understand that this I1 is flowing through the R1 and I2 is flowing through the R2, then you will be getting the net current is I. So in this case, let's, if we are assuming that like your R1 is 400 ohm and R2 is 390 ohm. So in this case, like this resistance, whatever you say, that this is like it is directly, we can say that load resistance also we can talk about this. R is equals to 1 kilo ohm. So in this case, if you want to find out the Vx, if practically if you will connect this R1, R2, here 400 ohm, here 390 ohm, here 1 kilo ohm, and if you apply here, for example, V1 and V2 of 1 volt, then you can see that what output you are getting Vx. Similarly, here if you apply 1 volt, what output you are getting, you can measure and you can find it out that how much it is there. That means you can find that like it's giving the mixing of this V1 and V2 signals. Okay, so let's see that more about that, how it is actually possible to get this mixing of this by analyzing this circuit. Okay,
So
let's
basically, it is a normal circuit, no?
This is normal circuit. That only I'm saying. In ESTC, just studying about the circuit. But application, you can see that this circuit is used in this application mixer circuit.
Okay, we are
Okay.
matlab basically we will study circuit along with its application. Like,
Means like why we are starting with the application, then the visualization should be there. Whatever you're studying the circuit, the use is there definitely in some devices or applications, right? This device you
okay,
can
ma'am.
use, and then actually real time we are using this device. But if you study this circuit, what is the use of this studying this circuit? You should know that, right?
Okay, ma'am. Okay, okay.
Ma'am, sorry to
So,
ask a doubt that is off topic, but I have received a mail that exam is rescheduled on 23rd of November.
means exam means yesterday your exam has been done, right?
No, ma'am. Actually, I didn't receive hall ticket for yesterday's exam, so I've written mail for support team. So they replied that my exam is on 23rd November.
November, they have rescheduled the quiz one.
I don't know if it is quiz one or quiz two or
No,
both
ma'am, quiz
combined,
Ma'am,
one
ma'am.
was held yesterday.
so ma'am, there are two exams actually. Quiz
I
one
think
this month
there
also
is
there is
quiz
one.
quiz due on 23 of
Yeah, there is one on
November.
this month and one on next month also, ma'am.
So, yeah,
No,
quiz one,
ma'am.
quiz two. I think if you have missed the quiz one, then they might be taking the quiz one and quiz two together.
I didn't miss, ma'am. I didn't receive my hall ticket
No, no.
from your side only,
Yeah,
support side.
probably. Are you a qualifier or something?
No, I just applied in. I just applied last month in September.
So
Actually, you
I
have
don't
not.
have the idea about that. You can drop the email only. They will be responding. Otherwise, I'll
I
just
think
ask
Okay, ma'am.
otherwise. Okay,
Okay,
Komali.
ma'am. Thank
Okay,
you.
okay. So let's move ahead with the same circuit. For example, means if I'm going to solve the circuits, I can show you that how it can be used in this means like your mixer circuit. For example, this is source and source V1 and this is source V2. So if I want to find it out the like Vx, how can I find it out? I have to do some mesh analysis or nodal analysis. Let me take some loop. This is the first loop. Like I can say that this is V1, R1, then this R. Next loop, let me take with different color, let me use. And second loop, let me take this one.
And this is AC source or DC source?
This is actually in practice. I have shown this small means definitely this is AC source, but I am showing 1 volt 2 for analyzing easily. That's why I have written. But right now I'm just doing without taking any values. Normally, if you see the mixer, the sources will be in AC. Okay, for
Okay.
analysis, we can take this C. We can then we can understand that practically actually we are using AC. Okay,
Yes.
actually
Maybe you are
AC source.
applying KCL, KVL, na?
Mhm. No, here loop analysis I'm doing KVL. Yes.
Okay.
So the take me let me take this is loop one, this is loop two. So if I write the equation, can anyone help me? Like I'm saying this is plus, this is minus, this is plus, this is minus. So if I take this red color loop, then I can write,
I'm like plus V1
yeah, plus V1
minus I1 R1
minus I1 R1
and then minus IR
minus IR is equals
equal to
to
0.
0. Yeah, very good. So from this, I can write V1 is equals to
It will be I1 R1 plus IR
I1 R1
plus
plus
IR.
IR. Can you tell me what is I here? I is nothing but I can write I1 plus
I1
I2.
plus I2. Yes. Yes.
So I can replace this as I1
So it will be
R1
I1 R1
plus
plus I1 R1 plus I2 R2. I2 R.
I1 plus I2 R.
Yes.
I can write in this way also, right?
Yes, sir, yes.
Okay. Similarly, if I apply the loop, a second loop, then what will be the uh,
So, ma'am,
equation?
it will be minus IR uh,
Yeah. What is
plus
that?
minus IR.
Minus, I can write I1 plus I2
Yes, ma'am.
R
And then plus V2
plus V2
and then minus I2 R2 equal
minus
to 0.
I2 R2 equals to 0. So from this also I can write what is V2, right?
Yes, ma'am, it will be I2 R2 plus I1 plus I2 into R.
I can write I2 R2 plus I1 plus I2 then R. So I got this is equation 1, this is equation 2 from the two loop equations. Then finally I have to write the equation like I have to find that Vx. I can write Vx is how much? I into R I can write, which is nothing but I1 plus I2 R I can write, right?
Yes, ma'am.
Can I write or no? Okay, so what I am doing, this equations everyone knows that how to do, how to find out. I am trying to relate to the mixer, so that's why a little bit I am doing the modification in these equations. Like if I write this equation one, if I take equation one, so can I write the equation one as I will divide the R1 both the sides. If it is, can I write V1 over R1 is equals to I1 plus I1 plus I2 R over R1. Can I write? I just have divided R1 both the sides in this equation 1. Can you see? Can I write? If I divide R1, then this will be I1. If I divide R1, here R over R1 will be there. Is it clear? Okay.
Yes, ma'am.
So what I am doing, you can understand. So equation 2 also similarly, if I write, then I can write V2 over R2
But
is
ma'am, why
equals
we are
to,
dividing by R1 and R2?
I'm coming to that. I'm coming to that. So here I can write I2 plus I1 plus I2 R over R2. Can I write this equation? Can I write or not? Tell me.
Yes, ma'am.
Okay. So in this equation 3 and 4, if I'm taking this 3, 4, if I add, then I can get V1 over R1 plus V2 over R2. What is my objective is that mixing. We are trying to mix two signal, right? V1 and V2, two signals are there. We are just mixing. Mixer, how it works, that I am going to write. So the equation form. That's why after solving, I got the equations, two equations, but I have to show that in mixer how it works. So that's why I'm doing this all these things. Then you can understand that actually mixer output how it comes. Are you following me?
Yes, ma'am.
So till now, you just understood that mixer means we are giving multiple signals to the mixer. Then we get the mixed signal. So how these mixed signals used to come, that just I'm showing that. Are you following?
Okay, ma'am.
So here, by combining these two equation 3 and equation 4, so I can write this V1 over R1 plus V2 over R2 is equals to I1 plus I2. So I can take this I1 plus I2, this I1 plus I2 as common. Then I'll be getting 1 plus R over R1 plus R over R2. Is it clear? So can you see these part are totally means like depending upon the resistance. or kind of we can say that constant values. Those values will be designed values. We have to assume these values, and we have, and this depending upon this I1 I2 and V1 V2. So this if this equation, if I used to make it totally in form of like I1 plus I2, means we are giving the two current signals I1 plus I2, then from this equation, this I1 plus I2 will become V1 over R1 plus V2 over R2 divided by 1 plus R over R1 plus R over R2. That means we can say that in this circuit, you can see that these two sources are there. From this source, you are getting I1, and this source I2. Then output you are getting I. So I'm getting here also output as the I is nothing but I1 plus I2. And these outputs are coming from this source V1 and V2, which are connected to the resistance R1 and R2. Right. So finally, we have to find the Vx. What is the output voltage of this circuit? This Vx is nothing but IR or I1 plus I2 into R. So if I am writing Vx, Vx is equals to your I1 plus I2 multiplied with R. This is nothing but is equals to whatever we have got it here. We have to multiply only R. That means V1 over R1 plus V2 over R2 divided by 1 plus R over R1 plus R over R2. This is nothing but I1 plus I2 multiplied with R is giving you the Vx. Clear? So if I want to write this only in terms of your source, that means your Vx is this Vx is the output of this circuit. This Vx is the output of the circuit. Input is V1 and V2. My goal is that I have to show that Vx is the mixing of two uh, signals V1 and V2. So from this, if I write then, and this I can write this way: V1, V1. Okay. So if I take V1 over R1 divided by this one, then I can write this one is nothing but V1 over R1 multiplied with R divided by 1 plus R over R1 plus R over R2. Similarly, other part I can write V2 over R2 multiplied with R divided by 1 plus R over R1 plus R over R2. If means in the previous example I have told you R1 equals to R2 equals to, if I take 400 ohms. Okay, this is 400 ohm. Then R is equals to 1 kilo ohm. These values, if it is known to me, only V1, V2, I can say that if I substitute this equation, I can get Vx is equals to some constant value alpha into V1, some constant value I can say that this is alpha 1, this is alpha 1, and this is alpha 2, V2. Can I write in this form or not?
Yes, ma'am.
So what was the goal? I was trying to show you that the whatever the output we are getting Vx here, this Vx is nothing but a mixing of two signals with some constant value alpha 1 plus V1, alpha 2 plus V2. That means these two signal, if I'm giving to the mixer, if I take one mixer circuit, if I'm getting the V1 and V2, then I'm getting the output with the mixing of these with the subscale, means L1 V alpha 1 V1 plus alpha 2 V2 means what? Some scale means what? You have to increase, you have to decrease, all the control will be happening with this. Then only will be getting the mixed signal, that is mixer signal, which is actually we are hearing. And this V1 and V2 are nothing but related to the mic 1 output and mic 2 output. Is it clear to you?
Yes, ma'am.
Yes,
Clear.
ma'am.
Real time, actually it happens. So for example, I have shown with the means signals, means two mics. Multiple mics are there. For example, 64 channels, and whatever I said, that if you are going for the big concert, then there are 64 channels used to be used. 64 channels means you will be having the 64 sources. That means 64 V1, V2, V3, V4 of the V64, right? So that time output, how can you realize? That also will be like discussed in this week course, the with the concept of superposition. I'll be discussing that also here. So the concept of this is clear, right? How the mixer is designed.
Yes,
Yeah,
ma'am.
yeah.
Okay.
And basically, what we
So
change the values on input and changes the output.
yeah, this alpha 1, alpha 2, you have to control so that you will be getting the mix signal, whatever that is the mixing of this V1 and V2.
Okay, ma'am.
Okay. And this alpha 1 and alpha 2 are nothing but you can say that alpha 1 is your R over R1 divided by 1 plus R over R1 plus R over
And
R2.
these are
Similar.
formulas we have to remember.
No, no, no. It's not required to remember.
Okay, okay.
Just you see that what we
Just
have
for
done
understanding.
finally.
Okay.
Yes, yes, understanding. So it is not required to remember. You should
And this
understand that
equation,
how.
ma'am, that
Yeah, tell me.
the equation we did till now, is it
Yeah,
important?
important means what you should know about this, how the mixer works.
Okay.
Okay, so that only I have explained how it is.
Okay.
So
Yeah,
in the case of circuit, there is no need of remembering anything. This is mathematics. You have to solve.
Yes.
Okay, remembering is not required.
Okay.
This is clear or not, this concept? Only the concept fundamentals clear means any circuit you can solve it. Okay.
Yes, ma'am.
So, for example, means I can tell you here, if I take the Vx value, for example, I can say that Vx is equals to 0.6 V1 plus 0.4 V2. So you have to understand that here alpha 1 value is 0.6 and alpha 2 value is 0.4. That means the these values you have to or know whenever your mixer designing you are doing, what will be based upon this alpha 1 and alpha 2 value, you have to take the R1, R2 values
Yes.
designing whenever you design the mixer,
And
right?
basically, this is the concept. Now, like uh, in the mixer, uh, the final Vx will basically summation of V1 and V2 multiplied by
We can
some constants, basically.
yeah, we cannot say that like summation mixing we can say, because
Mixing.
we are mixing two signals with some ratio,
Yes,
right?
ma'am. Yes.
Okay,
Yes.
so this
Okay.
Yeah,
is
I
the
think in
concept.
the lecture, the sir was tweaking the potentiometer, so he was getting different Vx with respect to that.
Pardon, I was not able to hear you.
Yeah, am I audible?
Your voice is breaking.
Okay, I think then there is some network problem. That's fine.
Yeah, tell me. Mohammed, you are saying something.
I think sir was using the potentiometer like to change these R values, so ultimately getting different Vx's like in the lecture. I
Yes,
guess.
yes. Yes, yes. Actually, whenever you are changing the R values, then definitely this weeks will be changed. Okay. So normally this is whatever I'm showing, you apply, like for example, if I take here like V1, V2, V3. like this, you are giving a number of like inputs to the mixer, like V N. So that time, by mixing this all the signals, you have to get the single signal whatever Vx. This is with the some like you can say that some ratio V1, uh, V1 V1, V2 V2, plus up to you will be getting the Vn Vn. Okay, and this is nothing but this multiple source signals are there, like V1, V2, Vn in terms of electronics whenever we are studying. But in terms of mixer, if you see, multiple frequency signals are there. Okay, like someone is using like you can say guitar, someone is using drum, someone is using like in your concert many instruments are there, and someone is singing. So multiple frequencies, multiple signals, but you can hear together everything, is it or not? One mic is
Yeah,
connected to your drum, one mic is connected to your guitar, but how all the signals together you are able to hear the concept behind it. One is this one only, mixer. How this, definitely this is designed right by the electronics engineers. Is it clear?
yes, ma'am.
Okay, can I go ahead?
Yes.
Yes, ma'am.
Okay, so let's see, like same circuit I will take, and you can see that how means we have to do the analysis more on that by changing this voltage whenever you will be coming to the lab. So you should understand that whenever you are measuring, is the measurement giving you correct value or not. So from this analysis only you can understand. So let's see, like I told you, in the mixer definitely you are using input as the AC signal, but for analysis we are considering this is DC signal to, means like do the easier method to understand the concept. Okay, the same circuit if I am
And this is
using.
another example you're taking.
Pardon?
And this is other example you're taking.
I'm just trying to and do the more analysis on this.
Okay.
You are good with this, but still I'm trying to do more analysis with the two sources. If you are taking this is V1, this is V2, this is R1, this is R2. So let's take this is 400 ohm. This is also 400 ohm, whatever the values I have taken before. And this is R3, which is 1 kilo ohm. So now I have to find this plus minus Vx. So if I apply V1 is equals to 1 volt and V2 is equals to 1 volt first. Okay, case 1. So can anyone tell me how what will be the Vx value you are getting
It will be less.
in,
It will be
in the
less
case
than
1?
1 volt, right?
This is 1 volt, this is 1 volt. Okay,
No, it will be that
so just
V
we have
alpha V or and beta V, adding that alpha alpha constant,
alpha beta you
adding that
forget, because
constant.
right now R1 R2 R3 is given to you, simply it has asked you 1 volt you are
So
applying,
it is like
and what will be the Vx value. So you have already done here
mm,
like whatever the values you can substitute, and
resistance
then
values.
you can do it.
Correct,
Okay,
correct.
so directly you can use also.
Mm,
For example, if I'm using directly this one, so Vx will be what I have written here. Vx is equals to V1 over R1 multiplied with R divided by this.
mm,
Okay,
mm.
so I can write here also. Like, let me write the same equation here, then I can utilize. Vx is equals to V1 over R
R1
multiplied with
into
R.
R. V1 by
This
R1.
is
Yeah,
R1 here.
yeah.
1 by R1 plus 1 by R2 plus, sorry, R by
No,
R1, R
R1,
by
R1.
R2.
Yeah, one, one plus.
Yes, yes. This is 1 plus R over R1 plus R
R over
over
R2.
R2. So, why I'm telling this in this form? Why do you know? So, if you are going for multiple sources, this is again means like Vx. You have taken this is for source one V1. This is source V2. Multiple sources means there is no need to like solve again and again. You can add here only
Hmm.
with up to n number of voltages. How I have shown you. Okay. Similarly, here I can write if I have the second source like V2. So I can write V2 over R2, then multiplied with R divided by 1 plus R over R1 plus
plus
R
R
over
upon R2.
R2. So similarly, if I say another source, if I connect in this circuit another source, then you can just plus V3 over R2
And
multiplied
same process
R
we had to do.
divided. Yes,
Okay,
and number of so this way easy to like if you have a number you can add it. So right now if I say that this is 1 volt source I'm taking, if we are doing more analysis to understand this concept, so if I'm
okay.
saying that 1 volt, 1 volt, if I have applied V1 V2, if I am applying here, then what will be the Vx value? Anyone can tell me? You just substitute and find it out. Tell me the answer quickly.
Ma'am, 1 second, just waiting.
You'll be getting around 0.83, so or not. Yes. Can you
Yeah,
check?
yeah. It is 0.8. Point 0.8.
Okay. So
Both put together, yeah.
next task is that if you're taking 2 volt and 1 volt, also you can check. If you're taking this is 1 volt and this is minus 1 volt, also you can check. So of what you, for example, if you're coming to the lab, you have to connect this same circuit on the breadboard, and it will be asked that to change this voltage sources and check
Hmm.
that what the outputs are coming. So you can calculate in this way and verify by using the multimeter. You can connect across this two and then Vx you can measure and you can see the measured output and the calculated outputs will be coming same, right? So this way you can also check it, right? So going ahead,
So
let's see.
basically,
Yeah,
ma'am, so
yeah.
the Vx will be always much less than whatever is the input voltage because of the dissipation in the resistors, right?
Yeah, that is like concept that absorption is there due to
Correct.
that. But major concept is here, like you are mixing more than one signal whenever. The
Hmm.
concept is that whatever the inputs you are applying, so how you are mixing it and you are getting
In
the
terms
output.
of
Here,
DC, it is easy to calculate, but then in terms of
uh,
AC, how is the phase shift and how is the amplitude?
phase shift is not, see whatever you see in the mixing, we don't care about the phase shift right now. We care that if you have taken one AC signal here, another AC signal here, then if whenever you are adding based upon the amplitudes, you can see that shifting. For example, if I take this is the AC signal, this is the DC signal. Okay,
Hmm.
this is DC of 1 volt, this is AC of 2 volt. I
Hmm.
can see that the 2 volt signal will be shifted up. This should be
Correct.
2 volt.
Hmm.
Now this should come, this will be coming to
3
plus
volt.
1 volt at the
3 volt.
output.
Yeah,
3
3
volt,
volt. Yeah,
3
maybe.
volt.
Yeah. No,
Yeah,
no, that is
that you
fine.
can,
The I mean,
yeah.
what I mean, couple of sources we can assume so, but when you are talking about 64 channels, you are assuming that all the wavelength will be totally different, right? Of different instruments and all of that. So,
Yes. Majorly in the case of mixer, what you are doing, you are mixing multiple. For example, you can say that whatever we are using microphone, you are just using the microphone with the small sound level. Like you can say that I am talking with lower level, but people are hearing very high level, right? Amplification kind of things is happening as well as mixing is happening.
That's why the diaphragm of the mic is little and diaphragm of the
Yes.
speaker as much great as they sound according to their sound quality and limit.
Yes. Yes. And here, whatever just showcasing and discussing that how the mixer circuit used to be designed. So this is the like way of designing the mixer circuit. Because
Okay.
whatever the mixer device you used to see inside that device, definitely some circuit is there, and that circuit how it is designed that only discussing here.
Yes, ma'am.
Is it
There
clear?
are some potentiometers and there are lot
Yes,
of resistors
yes,
according to
yes.
their, yes,
You have to vary this.
capacitors.
Uh,
If we
uh,
want much bass, and therefore there are so many capacitors to increase the bass and treble also.
Yeah, I'm not coming to that. Potentiometer you have used like a word. So, for example, this is my potentiometer. I have to control this resistance to get the good sound or good voice. Okay, those
Yes,
kind of things also used to happen. So, this is
yes, ma'am.
the just concept of this mixer circuit. Okay.
Yes, yes,
So majorly here from this study, what the outcome is that like you are able to mix two or more than signals with A1, A2, whatever you are saying with some scaling, you are able to add multiple signals, right? Okay,
yes,
so whenever you are adding these things in the case of circuit, like whenever we are doing the solving the circuit, we should know that. So any signal can be added directly, or any circuit in the circuit, any circuit can follow this addition, or I can say that this is nothing but some kind of linearity case. Okay, or you can say that linear circuits which will follow the linearity. What is the meaning of this linearity? I should understand. Okay, so for example, if I take this is one network. Network means what? The combination of the circuit can be known as network. Okay, so in this network, if I'm applying the input, for example, if I'm saying that input is x is means in terms of either voltage v1 or v2, whatever, or i1 i2, whatever. Okay, so the output will be, you can tell that the output y is the function of will be the function of input, right? Is it clear?
yes,
If I'm applying V1, then I will be getting here Vx, whatever it is, voltage means I should get here voltage, right?
yes,
So if I take the same circuit or same network, if I apply the input is A times X, means some scaling is there, then
yes,
output should be Y should be the function of AX, right?
X,
And when this like output f of x is equals to a types of f of x should also satisfy, then means whenever we take another network n, I will apply b of x, then output y will be b of f of x. So if I apply the another network which is the combination of, like I can say that means I can talk about like ax plus bx. If I am applying the output of this of y should be f of a of f of x plus b of f of x. Then I can say that this is just following the principle of homogeneity. Are you following or not? Are you following or not?
ma'am, what is the principle?
Yes, sir.
Yes,
Principle of homogeneity means what? Like, see, if I've taken this is, I can say that x1.
yes,
Okay. output is f of x1,
X1.
f of x1. If I take x2, output is f of
F
x2.
of X2.
If I take input is x1 plus x2, then output is f of x1 plus
1 plus
x2.
X2.
Okay, so if I apply here this f of x1 plus x2 is equals to f of x1 plus f of x2, then I can say that it is homogeneity. But it does not satisfy always. How?
And basically,
How
f
always?
of x1 plus x2 should be equal to
For
f of x1 plus f of x2.
whenever it satisfies, that is known as homogeneity. That is known as
Okay.
when
Okay.
it satisfies. But it doesn't satisfy always. For example, if I say that I am applying input as x1 square here, x1 square, x2 square. So here, then I have to apply here x1 plus x2 square. So then f of x1 plus x2
X2 whole
square
square
will not be equals to f of x1 square plus f of x2 square. Will it be? Will it be? No. Are you following or not?
no.
But if it's
That
x1 square plus x2 square, then it should hold true, right?
so that's why this is not following the homogeneity. Is it clear?
Yes.
Yes.
So this is nothing but known as homogeneity. So
Remember,
why
if
I'm
it
talking?
in any case it becomes equal.
No, it will not be equal. Means if it is see x1 plus x2, somehow we can say that linear. This is square is coming means this is non-linear, right?
Okay.
Ma'am, what happens if it is
Okay.
x1 square plus x2 square?
If this is x1 square plus x2 square plus 2x1 x2 it will come. So that's why it will not be same, right? But in this case it is same. So that's why we can say that this principle is nothing but known as a homogeneity principle. And if your any circuit or any network is linear, it should satisfy this homogeneity principle first case. But it is not the enough. We have
Ma'am,
to also see other. Yeah,
so if
ask
it
me.
satisfy homogeneity principle, so basically for what the satisfaction should be, like, what we can say after that, that it
Then
is a mixer or not.
mm, yeah, no. My point was that so mixer whenever we have seen we are able to see that we are able to mix multiple signals, right? Multiple signals. Whenever we are mixing multiple signals, it should you can see that this equation is kind of linear equation, right? Linearly a1 v1 a2 v2 linearly they have multiplied and added up. So
Yes,
that
ma'am.
means this follows this equation is linear equation. So whenever you are going for testing the linearity, the network is linear or not. Okay, how to test this
Okay,
linearity?
so it is done by
So
homogeneity.
yeah, so linearity should follow that homogeneity, or you can say that homogeneous. So homogeneity plus additivity. Both the cases should be satisfied. Okay, so I have shown a linear here actually at a time, the homogeneity and linear additivity. For example, I will again just repeat here. If I apply here x, then output y will be f of x, whatever I'm getting. If I apply here ax, then output y will be f of ax, which is nothing but a of f of x. This is nothing but known as a homogeneity.
Ma'am, how
Okay.
can you say A of f of x?
For example, if I say what is this function? Function means what? I can take multiplication
Yes,
function as,
ma'am.
for example, y, here I can say multiple of 2, then y will be 2x.
Yes, ma'am.
Okay. So here if I am saying ax, then the function will be what? Multiplication of 2. That means
Yes,
I
ma'am.
can say that 2ax.
Yes, ma'am.
Okay. That means I can say that this is nothing but a of 2x. That means whatever the input means, like you have applied with the multiplication of 2, the input is nothing but 2 of ax. So this 2 of ax can be written of a of 2x or not. So in that way I can
Okay.
write also.
Okay.
Okay, so this is nothing but your homogeneity. This is homogeneous. Scaling can be possible. So whenever you are taking this addition also, additive is also possible. So here you can see that your homogeneity plus additivity is satisfying this equation. Are you following or not? Okay, this is homogeneity plus additivity is following. When in this case, these two homogeneity and additivity followed, then you can say that this is following this linearity. So we can say that any network, if it is linear, then this is following the homogeneity as well as additivity for your understanding. So normally we have to see that in an electronic circuit, which are linear, which are non-linear. If we are using any circuit with the registers, means I can say that one network with the registers, all the resistive circuits are there, then is it linear or not a linear? How to find it out? How can I know that this is linear or not?
Like check the homogeneity plus additivity.
Yes, homogeneity plus additivity, but we know this is not
Yes,
required
can you
also that.
relate with that electric resistors? How it is?
Yes, if you're taking this as voltage, this is current. So your resistance used to be taken as like this slope, right?
Ma'am, which circuit, ma'am?
Any
Like
circuit
resistor.
if you're taking, any circuit if you're taking,
Linearity.
the correct, yeah, if it is the register is always linear.
Yes, to the current
Linear or not?
volt.
Yes,
With
yes,
the
ma'am.
current and voltage, whatever you are, can say, if you vary, always you used to get that this is linear in nature.
Because it's a straight line, so it's a linear.
Yes, ma'am.
Yes, yes. Okay. So, similarly, if you take any means like capacitive circuit, forget about the register. Is it the linear network? The network with the capacitors also linear or not? How can we test it? We used to write here capacitor is nothing but means if we take this is I is equals to c dv by dt, we used to write.
Yes.
Differential.
Okay. And derivative and integration also, derivation or integrations are linear or non-linear operations?
Non-linear.
Non-linear.
Pardon? These are linear operators. Go back, check in your mathematics, these are the linear operators, derivation and integrations. So whenever you apply this current or voltage relationship, either integration or differentiation also, so it also will be behaving as the linear. So similarly, if you take inductors in a network with the voltage sources, whatever you are using here, we used to write L di by dt is nothing but your voltage VL. So this is
Also
also linear
linear.
because derivative also. So we can say that linear elements are the resistors, capacitors, and inductors. They are linear in nature. So whenever you are dealing with this, then we can say that the circuits are linear circuits. So why I talked all these things? Definitely in the mixer, we are adding all these signals. So it should follow the linearity. Okay. And next is that uh, if I come to this mixer circuit, we have multiple sources. If we have n number of sources, so how to solve the circuit? So if you remember in the last sessions also, you have studied
Ma'am,
about the
how can the like mixer be non-linear? Can you explain with an example?
no, no, no. Non-linear is not possible. If it is
Superposition theorem.
non-linear, then you cannot mix the signals.
Okay, okay, that's
Okay, so that's why this superposition comes to the picture whenever see started with mixer, then I have told about this homogeneity, linearity, additivity, whatever. So ultimately, you have to come to this superposition. Means in the
Okay.
mixer, you are adding two signals like V1. You can say that V1 and V2.
Source and voltage sources at the same time, like that.
Yeah, means like whatever the circuit I have shown you. So there also we can apply the superposition theorem, right? And
Yes.
superposition theorem, when can you apply? If it follows the linearity, right?
Yes, ma'am.
So I just talked about that. Linearity is what? It should follow the homogeneity as well as additivity.
Yes,
So
ma'am.
ultimate right now, whatever I am talking, you have studied about the superposition, but you did not know that where is the use, why we are doing. In the last class, I think someone asked me if it is easy to solve the circuit by using the KVL, KCL, mesh analysis, nodal analysis, then why to go for the superposition? Because we have seen superposition used to take long time. Well, means
Yes.
that you have to see, for example, in this question, I have to ask that you have to find out the Vx. So in the case
We
of
had to
Vx,
find with first one
uh,
V1 source, and then we had to
V1,
find with V2
V,
source.
yes, V1x, then V2x, then you have to add Vx is nothing but the effect of V1x and V2x, then only you will be finding out, right? So in this
Yes.
case, it was taking lengthier, but application is what? Application, you can see that whenever you are using mixer circuit, then if you have the n number of like sources, then this superposition effect you can understand,
Okay.
right?
Okay.
So the application is that only. The useful of the superposition is in the case of mixer.
Okay.
Is it clear?
Ma'am, the whole mathematical expression we did, it is to explain
Hmm.
that relate with the superposition theorem.
Yes, yes, yes. In the electronic
Okay.
circuit theory, everything
Okay.
is superposition. Yeah. And
Ma'am,
the
because
application is mixer. Application is mixer.
because I understand circuit very well, but when I see that mathematical expression and the thing, then I feel like anxiety. I had some anxiety, like a feel from mathematics, so that's why I
No, no,
can't
no,
relate
no.
with
You
that.
should not. You should not. You should try to relate everything. First
Okay.
of all, whatever you are studying, you should
Yes.
know what is the importance of this studying this subject topic.
Yeah.
Definitely, it
For my
has use
for
somewhere.
my skills. Yes.
Somewhere we are using real time, right? So means like I said, amplifier or a mixer circuit you are
Yes.
using, so that you know that mixer. But whatever you are studying, you know, but you don't know the relation,
Yes, ma'am.
right? So now
Yes.
it is easy to know the relate, and you cannot blindly say that any input we can give it. Like I said, it should follow the linearity. So those are the fundamentals. It should be clear.
Yes, ma'am. That's
Okay.
why we are learning with the circuits and basic kind of things. Then we are going to superposition, then networks, all that thing.
Mhm. Okay, let's go ahead. Last session, I told about the voltage divider, something current
Yes.
divider. I did not say, but I will show here something easy way, so you can yourself only understand that how to series and parallel circuit whenever you are dealing with that. How to. So let me take one case. So if I am taking one battery. So if you go through this week 5 lectures, then you can see that all these things are already have been discussed there. So I'm
And
just
these are
discussing those
questions
things.
basically.
These are the summary of the week
Oh,
5
okay, okay. Oh,
lectures. All the lectures have been discussed based on this, whatever I'm talking here. So, for example, this is your voltage source. 1 volt is there. 2 kilo ohm resistors are connected in series, and it was asked you to find out the voltage Vx. I think similar kind of questions also you have done in your exam. Okay. So here, if anyone will ask, how can you do it? Definitely, you will apply this KVL or loop analysis you have to do. Then I can write this is nothing but 1 volt minus 2 kilo ohm I. For example, I'm saying current I is flowing here. Then minus 2 kilo ohm I is equals to 0. Right. So from this, I can find I is equals to nothing but 1 volt over 4 kilo, which will give you 0.25 milliampere. If I get the current, then I can find out the what is Vx. Vx is nothing but your current I multiplied with 2 kilo. So it will give you around 0.5 volt. So here you are getting 0.5 volt. Here also you will be getting 0.5 volt. That means whatever the voltage you are getting here, the same voltage is applied at the source. Right. So if
Yes,
I
ma'am.
write without values, if I say this is R1, this is R2, this is V1. So I can write this I is nothing but is equals to V1 over R1 plus R2. Can I write whatever I have written here? V1 over R1 plus R2. Can I
Yes,
write?
Yeah, yes.
yes,
If
ma'am.
I if I want to write Vx in terms of R, this Vx I can write I into R2.
Hmm.
So I can substitute this one, that is V1 over R1
The
plus
one plus
R2
R2. Yes.
into R2. If you remember in the last class, I discussed these things only. So this is your voltage Vx across this R2, but total voltage is known to you. Then you are getting that voltage corresponding resistance divided by total resistance. Similarly, someone will ask you to find out the voltage across R1. For example, I say that this is plus minus Vy. Okay, across the Vy I can write directly. This is nothing but IR1. This can be written as V1 over R1 plus R2 multiplied with R3. Sorry,
R1.
this will be what? R1. Okay. Similarly, if you will be having multiple series resistances, so there is no need to do multiple steps. You understand that total voltage is divided among across these registers, and you have to apply this. So it is easy to apply and find out in any circuits solving you whenever it will be easy for you, right?
Ma'am, can if R1 and R2 are in parallel, does it still like do we take like 1 by R1 plus 1 by R2?
Can you repeat your question? Actually, some echo is happening. Means I am not able to hear you properly.
Am I audible right now?
Yeah, yeah.
So like let's say if R1 and R2 are in parallel.
Yeah,
So
yeah, I'm coming
now,
to that. I'm coming
But
to that. I'm coming to that.
yeah.
So
voltage
in
across
this
the
case,
parallel resistors is same, na, ma'am? Parallel resistor.
voltage will, yes. Last class only I talked. See, here my focus is that whenever yours means like registers are in series. Okay.
so basically, we
So,
just doing trying to analyze the circuit, na? Circuit
so high,
analysis basically.
but this is very important concept
Okay.
to solve the circuit.
Voltage dividing rule, ma'am.
Yes.
Ma'am, can you also
Voltage
take
dividing.
capacitors, for example, like in series?
In this case, you just tell me what it is happening. Total voltage is getting divided among these two resistances. Here same
Yes.
resistances I have taken, so you can understand that same voltages we are getting. But if I change it is 1 kilo ohm and this is something 3 kilo ohm, the resistance voltage will be different, right? But the addition of this total voltage will be same as the source voltage.
Yes, ma'am.
Welcome. Okay,
Yes,
this is
yes.
the concept of the series resistance. So in this case, your voltage gets divided, but current remains same. That already I discussed in the last session also,
Yes, in
right?
series current stream.
Yes. If I go to the current sources, like for example, if I go for the current source, for example, I take similar kind of circuit. I'll just connect one current source here. Sorry. In this case, like if you take the resistance in parallel, here your current I, if I am saying that this is your I1 and this is your I2, this is your I1 plus I2, right? So here voltage across this all the resistors will be same. Like I can say
Yes,
that this is Vx plus minus. So if I used to do the analysis, how can I do the analysis? I can say that this Vx is equals to this Vx. That means Vx I can write I1. This is I. Let me say R1 and this is R2. And I can say I1 R1 equals to I2 R2. Can I say or no?
yes,
Because
yes, ma'am.
the voltage across this is also Vx. This is also Vx, right? And here, if I say that KCL, if I apply, then I know that I1 plus I2 is equals to I. Is it or no?
Yes,
So from this, if I apply, I can say that this is your from this. If I take I1, this is I1. I1 is
yes,
what? I1 is nothing but I2 R2 over R1.
plus R2.
So here I can say that yeah, I2 R2 over R1, right? So here, if I substitute I2 R2 over R1 plus I2 is equals to I. Then this equation I can write that this is your I2 I can take common, right? I can write here R2 plus R1 over R1 is equals to I. So if I
Yes,
write this one in case of I2, if I want to find I2 is equals to total current I R1
into
over
R1 upon R1 plus
R1 plus
R2.
R2 I can write. Can I write or
Yes,
not?
yes, ma'am.
So similarly, if I want to write I1, I1 will be what? I
R2 into R2 up
R2
upon
R-
R1 plus R2.
R1 plus R2. So what
Yes,
difference you got it here? So you are finding current I2 means current I2 means I2 is through the resistance R1, right?
yes,
And current I1 is through the resistance R1. So you just got the opposite means like way I2 is whenever you are finding out R1 is multiplied with I, and I1 whenever you are finding out I is current
total
multiplied with the
current.
R2, just
We
opposite.
had to multiply with total current. Total current, na ma'am? I
Total,
means
yes, total current opposite
in the
resistance
circuit.
divided by total resistance.
Yes,
Means if I want to find the I2, that total
we
current
had to.
multiplied with the opposite resistance divided by total
Yes,
resistance.
yes,
So this is little bit different from your voltage divider. That total voltage with the corresponding same resistance divided by total resistance. But here in the current parallel case, what you are doing, total current, the opposite resistance. In which resistance in which resistance you are finding out the current, you have to take the opposite resistance divided by the total resistance. But
yes,
how you are reaching to this? Already this analysis says that you are reaching to this point. Is it clear?
yes,
Means
ma'am.
how this formula has come out from the analysis we got it. That means it is clear, right?
Because the total current is divided in two parts. If we
Is
find
it clear?
across it, then remaining current goes through it, this like that.
I'm not getting. Can you repeat your question?
Like two resistors are connected in parallel, so I
Hmm.
total divide in two parts. If we find across R1, then remaining
Hmm.
current goes through R2. We can
Yes.
find like,
So
yes,
here, yes, yes. Here, what happened? Your current divides between these two resistors, but voltage remains same. If I say that if this is 5 ampere, then if 2 amperes goes here, then 3 ampere comes through this R2.
yes.
Clear? So this is the concept of the series parallel, voltage divider and current division, right?
Can you explain once that voltage dividing rule?
Yeah. If your resistors are in series, forget about
Yes,
what voltage divider, what current divider. But if you do the analysis, you know that series means same current will flow through that and apply the KVL or loop analysis. Then
yes,
whenever you are applying, then you are finding out that this is V1 means plus V1 minus I1 R1 minus I2 R2. Sorry,
yes,
IR2 is equals to 0. Finally, you are getting that your from that whenever you will find V1 or current I, whenever you are finding out current I is equals to total voltage divided by R1 plus R2,
R1 plus
right?
R2. Yes,
Okay. So
yes,
now I need to find it out the voltage across the R2. That means I have to multiply I with the R2.
yes.
That means I value is V1 over R1 plus R2 I got. I have to multiply R2. Then this is coming this.
Okay, 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 ma'am. I get it.
Okay. Got it?
Yes, ma'am.
Okay.
We
So
had
is
to
there
got
any doubt?
total voltage upon total resistance into resistance in which we had to find multiply with that resistance
Yes, and in case of
voltage.
current division, you got opposite. Like current,
Yes,
if you want to find through the R2, then you have to multiply total current R1. Means R1
yes, ma'am.
you have to multiply here. Here you observe this from this analysis.
Yes,
Clear to everyone?
Yes,
Okay.
ma'am.
So, okay. So, if means this voltage divider, current divider will help you in case of whenever you are doing the complex circuits, directly you can apply and do it. So let's move ahead with the superposition. So in the case of superposition, already we have discussed before. Right now also I told you, it should follow the linearity. That means like homogeneity and additivity it should follow. So let's take one circuit with voltage source and current source, like plus minus 2 volt, let it be. Just let me draw it, space is less. This is 4 kilo ohm and this is 2 kilo ohm, this is 2 volt source. The current Ix you have to find by using superposition. This is 1 milliampere. So
Ma'am, is
that
this
means
question?
yeah, this is the question.
Okay.
You have to find out Ix is how much using superposition. So how to do it? You know that you have
yes,
to
ma'am.
first
We had to remove one
uh,
source. Yeah,
yes, de-energize one source. For example, if I'm de-energize 1 milliampere, this is case one. Then the circuit becomes like this is plus minus 2 volt. This is 4 kilo ohm. And this will be behaving as the current source means open circuit, right?
Yes.
And you will be getting 2 volt. This is 2 kilo ohm and this is 4 kilo ohm. So at that time you have to find the Ix with the effect of this. So let me call it Ix1. Can anyone tell me Ix1 is how much? How to do it? Just directly apply the KVL.
Ma'am, I got 1.3. If I took
You got 1 over 3 milliampere, right?
no, and first question, total voltage, ma'am,
This
across.
one.
If we go with 2 volts, then I got 0.3 amperes. We had 1 ampere. That
0.3.
Yeah. Whenever you are taking the case two case, the circuit will be this is short circuit.
yes, with two. Yeah, then short circuit.
Let me call this as Ix2. This is 4K. This is 2K. So in this case, Ix2 is also 1 by 3 milliampere we're written, right?
Yes.
Then total Ix is nothing but 1 by 3 plus 1 by 3, that is 2 by 3 milliampere. So this whenever you are doing means this superposition is possible in case of linear, and we know that register is linear in nature. So that's why we are able to do it. Whatever we studied till now, the gist of
Yes.
this.
Yes. Ma'am, I had to find a voltage across the 1 ohm also.
Voltage across?
Like, ma'am, I only find the current due to the two volt source.
Yeah,
It is
because
0,
the
0.3 ampere.
the the question has asked Ix. You have to find Ix is this is the main circuit. This is the main circuit. Okay.
Yes.
Ix is the current flows through the 4 kilo ohm. And you have to find this Ix by using the superposition principle.
I
So
don't
that
know how
means,
to find across Ix. I only find the voltage if we remove the 1 ampere source. Then I
okay,
got a 0.3 ampere of current due to the
where?
2 volt source. 2 volt source.
Due to the 2 volt source.
Total.
That means here this current you got, okay, this current is nothing but same current as Ix1, right?
Yes.
Because no current flows here, I equals to 0 because open circuit,
Yes, yes,
right?
ma'am. Because we removed that. Yes.
Okay, that means this is a you got because of this 2 volt source, the current flows through this 4 kilo ohm is Ix1, which is nothing but is equals to 1 over 3 milliampere, which is nothing but 0.33 milliampere,
Yes.
right? So similarly, whenever you are going for the next case, you have to de-energize the 2 volt source. That
We
means
had to short circuit
that
that
will
2 volt.
be short circuit and 1 ampere milliampere. That time you can apply your KCL, right?
Yes.
Then you can find out the Ix2 is equals to 1 over 3 milliampere also, which is nothing but 0.33 milliampere also.
Okay.
Then finally, you have to find out the summation of the case 1 and case 2 will give you the original circuit's Ix value, which is nothing but 1 over 3 plus 1 over 3 equals to 2 over
Is
3
equals to 2
milliampere,
over
which
3.
is nothing but this is the effect of uh, due to the 2 volt source, due to the 1 milliampere source individually you have seen. Then if we add this, then we can find in this circuit this is, and this is only possible, this is nothing but known as superposition principle. This is only
Yes.
possible in
Yes.
case of linear case,
Yes,
and
ma'am.
this circuit are linear in nature because registers are there. Similarly,
Yes.
inductors and capacitors, if it is there also, we can apply.
Yes.
Clear?
Yes, ma'am.
So in this circuit, let's I'm just changing the values. You try by yourself. This is, for example, I'm taking minus 2 volt. This is plus 1 milliampere. What will be the case of to find out the Ix? You can check it for another case. Okay.
Okay,
This
I
case, if
will
you
try.
take 1 milliampere and minus 2 volt, what will be the question? And it's like Ix, you can find it out.
Okay.
Can everyone try?
Ma'am, what?
Hello?
Yes, ma'am.
Yes, you.
Ma'am, just change the value of that voltage 2 volts to minus 2.
Oh, okay, ma'am.
Then you can do it.
Yes, ma'am. 1 second.
Like, should it be zero? Like,
Zero
Yes,
for
ma'am,
total
0.
current. Total current?
Yes, ma'am.
Yes, ma'am.
Because 0.33 from 1 ampere source and 0 minus
Hmm.
0.33 from 2 volt source, minus 2
Okay.
volt source,
Okay.
then 0.
Very, very good. Okay. So now you are able to understand that how the superposition works, right?
Yes.
Yes, ma'am.
So just one case, I will let you know. If you are going for this current division case, whatever the formula you got it. So from this, what can we like perceive? This is I1 if I am finding, then I used to write R2 over R1 plus R2 total current I. So if I say that if R2 is much greater than R1, in this case, what will be the situation I2 and I1 relationship? Can anyone tell me?
R2 is
In
greater,
your,
larger.
in your, yeah, much larger than R1 in the parallel circuit if it is.
Ma'am, current across the R2 is less than R1.
That means I2 is much lesser than I1, right?
Yes. Yes.
Similarly, if R1 is much greater than R2, then
And current across the R2 is greater and R2 is small.
that means this is the case.
Yes.
From this we can understand that like whenever resistance is increasing, current is decreasing,
Decreasing.
right? So in
Yes.
this case, so this is all
Because
about your,
current choose
yeah,
the always choose the shortest path, and if there is long resistance, then current always choose the shortest resistance to
yeah,
flow more.
it's, yeah. So the correct answer is that less resistive path always current chooses. Okay.
Yes, ma'am.
Okay. So this is all about your revision from your week 5 lectures. So do you want to do some solve the questions or any doubt is there from your exam?
No, ma'am. No doubt.
So can we wind up today's class? You all are also tired, right?
yeah, yes.
Thank you.
Okay.
Okay.
Okay. Right.
Just a
Ma'am,
request, ma'am.
basically,
Like, hello.
thank you, ma'am.
Thank
Thank you.
you.
Yeah. Thank you, ma'am.
Thank you.
Ma'am, am I audible?
Yeah, yeah. Tell me.
Yeah, like since it's night time, so if it will be really good if you can shift that page to dark mode and write in the white like color.
Mm, I'm
like
not
it's
getting
since
you.
next. Yeah, I'm
Yeah.
saying like if you can get the page in the